Good morning, good afternoon, good evening, everybody. My name is John Wenena Karanja, founder and CEO at Melanie, which is a Web3 startup in the distributed energy sector. I'm also the co-founder of the Black Blockchain Summit, which is the reason we're here today with Dr. Shelby Donnell, who will be giving us a presentation on AI and genomics. AI has been a huge phenomenon in the last year or two. And we decided to add it as one of our key sort of sessions at the Black Blockchain Summit. And Dr. Donnell will be our keynote leading us into the AI age. So, Doctor, karibu sana. You're welcome to introduce yourself and the area of discussion for today.
Okay, thank you, John. Um, so I'm Dr. Shelby Solomon Darnell. I have a master's in artificial intelligence and a PhD in affective computing or getting computers to understand human emotion. Um, a few years ago, maybe 2.5 years ago, I started working with a genetics and genomics research lab. And November of 2022, we had OpenAI release ChatGPT 3, 3.5. And its capabilities, its ability to generate text and information that seemed quite intelligent, and being able to answer questions was revolutionary. And so some people have been, a lot of people the world over have been more interested in artificial intelligence. They are um, reinvesting heavily, and not everyone really understands what's going on. In fact, I was talking to a young coder last week and also today, and he thought that AI was something new, whereas AI is not new. Um, it began in
Yeah.
around 1948, and we've had several times different AI applications have been created that started a lot of hype in AI, and then funding went up. And then after people realized the full promise of these applications, there were AI winters, whereas people thought AI was trash. But what happens is, for instance, for one of the big hype ups of AI, we have expert systems. And expert systems um, try to act like experts, but they had been more limited because they had a listed control set, some boundaries that they couldn't go beyond. Now that we're looking at generative AI, we can put different guardrails on it that make an extremely powerful expert system that one would not be able to easily tell it wasn't a human intelligence. So, um, I really one of the reasons I'm into genetics and genomics right now is because I've learned quite well how to code for computers, and now I need to understand how human coding works because we have a lot of different things going on in this area, in the intersection of this area, and we can't be left behind because being left behind means being more exploited. And one of the reasons I'm very excited about this area is I also have a background in blockchain. I have a few patents and a few papers. I've implemented a few proof of concept systems for clients, and one of the important things that need to be done around genetic information is to make sure that the people from whom the genetic information is taken actually can control and own their information rather than letting other institutions control their information because it's wildly helpful and useful to research. So, if you look at evolution, if you think about evolution, and part of artificial intelligence is about evolving, making it so a computer system can better understand how to solve problems and how to retrieve information. And then when you look at genetics and genomics, that is supposed to map out human evolution as well as other organisms. And what's happening now is what do we call it? In 2003, the first full human genome was what do we call this? Transcribed, and it was about 90% of the full human genome. And now with each year, reading and processing a human genome becomes faster and easier and less costly. So I don't have the figures for how much it cost to actually what do we call it, transcribe the initial human genome, but we'll talk a bit more about that a little later. Either way, because of all of the information, um, let's say you can get a kit that costs $1,000 that allow you to sequence genetic information of organisms, and that is a very low price point based off of what it used to be because the Human Genome Project costs billions of dollars to actually implement, and because the barrier to entry to sequencing genetic information is lower, amazing amounts of genetic and genomic information are being produced. Um, Similar to how much information we produce by just being online and always being on our computers. Um, Now, along with that, you have what do we call it? The NHGRI, the National Institutes of Health Genomic Research Institution, or at genome.gov. And they're doing lots and lots of things. They have a whole uh, roadmap from 2020 that they're implementing, and we need to take advantage of these opportunities to get to participate in this type of research because diverse views and help reduce exploitation generally and help improve out research outcomes. Um, let's see, what's the next thing I want to talk about? Oh, and as far as a slightly bit more background on artificial intelligence, um, large language models are just part of machine learning models, and machine learning models um, started gaining a lot more popularity back in 2010 in the research field. And here in 2020, 2 years ago in 2022, like I said, OpenAI made a huge step forward um, with its natural language processing language model, ChatGPT 3.5. And as far as AI goes, natural language processing is just one of the facets of artificial intelligence. Uh, you also have evolutionary systems and and robotics. There are several facets of artificial intelligence. So let's move on. So this slide is just speaking to research that I'm pursuing. And as a new genomics researcher, genetics and genomics researcher, uh, I need to build up my I need to build useful tools while building up my knowledge of how genetics and genomics works. So there are a few problems on which I'm focusing, and that's strengthening our understanding of the black areas of a genome through the pangenome and computational intelligence. We'll explain what the pangenome is later, but you'll probably can understand or know what it is by just the prefix. How to build machine learning models that support the understanding of causation with existing data. Now, causation is a somewhat new area of mathematics and computer science research where uh, we're trying to understand what causes the change from one state to another because intelligent systems are never going to be able to reason well if they don't understand the causes of what made something change from state A to state B.
Yeah.
Right now, large language models, they don't understand causes of things. They are just very good at processing very large. Okay, a large language model has billions of weights, and the billions of weights have been trained on uh, petabytes of data or gigabytes of data. Some of them might be trained on petabytes of data, and the weights help them learn what should go after what word should go after the next word. That's why it's a language model. So if when you type in a question, it has already read so much information that it can come up with the answer based off of all the information that it's already read. So it's not actually reasoning, but it is what do we call it? Generating the next item in a sequence. And it uses
Would you say that
probability
is
and
would you say that is predictive analysis, perhaps?
it is predictive analysis
All right.
because it's looking at different probabilities on what it should say next and what it should do next. And then
Yeah.
it takes the thing that has the highest likelihood of being correct and pushing it forward. And it does it exceedingly fast. And
Mhm.
another research problem, I'm want to enable a faster understanding of complex research ideas and outcomes to better facilitate citizen scientists while speeding up the rate at which scientific knowledge is mentally consumed. Mouthful. So, my plan on getting to those points is to really pay attention to data science or to um, use data science and a comprehensive data science process to solve certain problems or approach certain problems in the genetic space, and specifically the problems that were listed on the last slide. So, for instance, problem three, enabling a quicker understanding of complex research ideas and outcomes. That's quickly enabled through a ChatGPT interface using something called retrieval augmented generation. Um, Now, when we're trying to when we're trying to enable a better comprehension of information, we want to make sure that we are not getting incorrect information. One of the issues with large language models in general is that they hallucinate, and that's just an easy way for people to understand. Um, because it's trained on such a large corpus of data, it can make up things, or the things it generates will not always be true because the amount of data it has to look at. Whereas with retrieval augmented generation, you're still using the strength of the large language model, but you are forcing it to only take information from a smaller corpus,
Mhm.
from I guess like a specific lookup table. So
Mhm.
with that, you are getting a lot less hallucination, um, and you can refer back to, let's say, the source from whence the answer was generated. The specific source. ChatGPT has, I think, has started to um, give you the source of the answer, or yeah, the source of the answer or what it generated, but it's usually a website. Whereas with retrieval augmented generation, you can be more granular with your source, like specific research articles. And so that's one of the first things that I've explored. And we're writing or publishing a paper about that in the next few weeks. And this has been done in different ways, but ours is quite focused on this platform called genenetwork.org that is
Yeah.
like a 30-year-old genomics database, but thankfully it the vast majority of its data is on rats. But we'll talk about, or not rats, but mice, and we'll speak to more about genomic databases. So I spoke about causation, um, and causal inference a bit earlier, and this slide just explains it a little better. So when you're looking at something like how does one get diabetes, you have to look at all the different things that help cause diabetes, that lead to diabetes. And so we map out this chart um, that shows you those different things. So causal inference uses lots of probability and statistical methods to get an algorithm to understand the cause of something. There's a very good
Wow.
book called The Book of Why, um, where this man, Judea Pearl, a Turing Award winner, you computer scientists should know what that is. Um, but and also Alan Turing is the pretty much the genesis of artificial intelligence. But either way,
Well,
Judea Pearl
I
came up with
he was
this
involved
causal.
in,
Say what?
uh, I thought he was involved in encryption.
So what happens is he was involved in encryption, and he also wrote the first paper on artificial intelligence. So
Oh,
the
okay.
so what is this? He was trying to do code cracking in one of the world wars, and as
Mm.
he was going through doing this code cracking, coming up with different algorithms to do it efficiently, he he was stumbling upon uh, artificial intelligence ideas, and he came up with a Turing machine and the Turing test. And the Turing test is supposed to evaluate whether or not a system is actually intelligent. A computer system, a digital system is artificially intelligent. So yeah, Alan Turing did encryption, but he also was father of artificial intelligence. Oh, and
All right.
let's see. So as a as I'm working on this research and implementing different things, we are also still trying to support uh, Kenyan what do we call this? Entrepreneurs and startups. So we use a system that's based off of ChatGPT by a company called Fahamu AI, run by a young Kenyan man that they call Digest. And what Digest does is ingest different PDF files, and then you can query their system and get answers from those specific PDFs. And we have worked with them to ingest 3,000 PDFs and about genetics and genomics research in the areas on the topics of genetwork.org, the database, the large genomic database that me and my research colleagues work with the most, that we've also created, um, at least that they created. And what do we call this? The genetics of aging and the genetics of diabetes. So we have a system with 3,000 publications that you can ask you can ask whatever questions you want around those topics. So one of the best things about using this system and using this large language models and retrieval augmented generation is it's extremely difficult to actually read all these publications and then generate a lot of ideas and see all the loopholes uh, around research outputs and about research results. So, and also when you have 30 terabytes of data of genomic data, you it's easy to forget um, how much value or underestimate how much value that data actually has. So when you have a system that can ingest all this information and you can start asking it questions, some of the results that come back um, can bring up long buried information that you know you most people would have forgotten. So one of the things that researchers, part of a researcher's job is to actually ingest all this information on their topic of interest, on their research topics, and then um, do background processing and come up with uh, different research directions. Or, uh, you'll just be looking for a specific, you like a certain area of research, you want to be funded, you look up some type of funding opportunity, and you start doing reading and coming up with different objectives based off of that. But either way, one of our jobs as researchers, or one of the jobs of a researcher, is to ingest a lot of information and be able to parse through it, understand it, and generate new information, or mm, or expose new information. We'll say we're not actually generating it, but we're exposing it. The information is already there, and we might learn of a connection that someone else hasn't learned of before, and we can publish things like this. So this is just an overview of things I talked about before. Not that important concerning this talk. So now let's talk about genomic databases. So as we speak, full human genomes are being sequenced and saved on private databases that are owned by universities and private companies and by the government. Um, and I think one of the only ways to try to curb the unintended uses and of databases like this is to make sure they're undergirded by a blockchain so that the owner of the genetic information and of the genome can control who gets to see their data. So let's say, for instance, you have a listing of 100,000 people, 50,000 black people, 50,000, let's say 40,000, 45,000 white people, and 5,000 people are mixed. And in this research area, they say add mixed for whatever reason. And let's say a group of researchers or a researcher wants to use that genomic information to understand something or to just do their work. What should happen is that people get prompts on their devices or through email that says, hey, somebody wants to use your genomic information. And you can say yes or no, or you can just opt in general, or you can just opt out in general. Right? Because we have black people in the U.S. around the world have a history of being exploited by advances in medical technology, and we don't have to look any further than this COVID outbreak, especially Africans. They they have some tales about how they were being exploited um, by nations with more power and more money to try to help forestall that crisis.
Yeah.
Say what?
Yeah. Yeah. I saw that on the news. Yeah.
Yeah, man. We're always being exploited. And then you have to think about what is this woman's name? Henrietta Lacks, whose
Mm.
uh whose cells have been used since she went to a doctor and they diagnosed her with cancer. Then they realized her cells are not dying, and so they're used to test different vaccines and everything else. And they have been used like that for the last, I don't know, ever since they took a sample of cells from her because they just keep multiplying and they're 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 immortal pretty much.
Yeah.
And they've been using her cells for decades without proper remuneration. companies have made billions upon billions, probably trillions of dollars. Pharmaceutical companies have made egregious amounts of money, and just recently have tried to, say within the past 10 years, have tried to give her family some of the proceeds, but obviously it's peanuts.
Yeah.
So, we'll look at when we're talking about genomic databases, you have to understand that there's research scientists in genetics and genomics attempting to increase the diversity of their genetic databases. Um, but it's difficult to increase the diversity in things like this because researchers in genetics and genomics are generally uh, white people, and
Mhm.
so when they look for volunteers, they're usually finding other white people, and that's it's hard for them to interact. It's hard for them to ask for other other type of people and get them to trust them with their genetic and genomic information. But they find ways around it all the time, and we can speak about those things offline. Um,
Yeah.
Another problem is that these researchers have stunted imaginations when it comes to fair use and ownership of data, especially data as important as a genome. And there have been research papers about this, how black people, like, what is it? It used to be common for black people to be genetically tested before they get into the army to see if they have sickle cell. And if they did, they were not allowed to get in the army, or it would keep them from having certain types of jobs. So this genetic testing has already been used against us. And, we have to be very cognizant of where we allow our genetic data to rest. And there are very bad laws and regulations about uh, the the how genetic information is handled and what's fair use around genetic information. So
Yeah.
there are policy issues that need to be addressed. A lot of policy issues, guidelines and guardrails for safeguarding genomic data are wildly insufficient and definitely don't empower the owners of the genetic information. Now let's talk about the genetic frontiers. Um, When we look at the initial reference genome, 70% of it came from one person of admixed background or blended ancestry, and the remaining 30% came from 19 white people.
Mhm.
Um, but it was but it really wasn't 30% because only 90% of the human genome could be sequenced. Now, I told you I was gonna bring up pangenomics again, and pangenomics is combining genomes from many people of mixed backgrounds, as many as possible, to create more powerful reference genomes for multiple species. So, one of the things research is trying to get to is making medicine based off of a individual's genetic information. So very bespoke very
Yeah.
bespoke medicine, and that shit's dangerous as hell. Um, it's wild. It really needs to be managed better. The whole pipeline.
Mhm.
Um, because right now it's in the mad scientist idea is not. A mad scientist doesn't always show that they're insane. Most mad
Mhm.
scientists seem exceptionally normal, and they're just excited about understanding and finding connections and learning new things. And if they learn how to get paid to do it, they just do it constantly and consistently. And what they're most worried about is whether or not they are following the regulations they need to maintain their funding. So we have to
Yeah.
be very wary of that. And again, we need to get into policy management and creating policy, and that's a bit of a slow road. But whether it's a slow road or not, we got to go for it.
Mhm.
And one of the things that NHGRI, National Institutes of Health Genomic Research Institute, um, one of the main things they want is to train all their genomics scientists in data science because they know all this because they've seen all this data being generated, and they want people to be able to use artificial intelligence to get more or understand more of their information. So all this needs to be bounded, and that's why I said we need to control genomic information with blockchains, so individuals can control their genomic information and genetic data, because otherwise it's just going to be wildly put all over the place and copied everywhere. There's research ongoing about how to um, protect genetic information. And when you make genetic information public, uh, use some do some add noise to the genetic code. So if somebody is to try to figure out who has that genetic code, they can't. But you know, that's mm, if when you add that noise to the genetic data, the scientists are making sure they don't add so much noise that they can't learn proper insights from the data. So
Yeah.
now, how much noise is actually going to be put in there, and how egregious is that noise going to be? So if you're trying to do a one-to-one a comparison, yeah, it'll fail. But you can use artificial intelligence to get a probability of who that genetic information may belong to. So again, we have to be careful. So that ends my presentation. John, do you have any questions?
Yes, yes, of course. You and I have been discussing and working together for many years, particularly on the blockchain side, using the distributed ledger for various applications in the energy sector. And now
Yeah.
you're talking about using the same ledger for applications in the genomic sector as well.
Yeah.
And you also happen to have made me an uncle to, three, nephews
Well,
and a lovely niece.
yeah.
So I know your kids have a great heritage in terms of, the different peoples they come from. So could you speak to that heritage and how we can use both machine learning, AI, blockchain, and the tech that you're working on in genomics to help Black people around the world trace their roots, for example? Is that something that is viable, and can it be done safely in a way that helps people instead of harms them?
So it can be done quite safely. So you already have several databases from different companies that have this information. And then you have some government databases. And as a research scientist, I can get access to some of this data and
Yeah,
do tracing myself. I'll write applications to do tracing. So, and then I can make sure the genetic information that I'm using is on a blockchain and the results are on a blockchain, and they are locked to the private keys of the people who I'm searching for. So so I can we can write it such that I don't even have access to the results. I can
yeah,
just calculate the results.
yeah,
So that would be an amazing thing. And so as far as the heritage and background, I'm black guy from Alabama, and like most people, most black people, especially from the south of the U.S., south specifically, well, South U.S. We I'm quite mixed. There are white people uh, as close as my great grandparents, Native Americans, my grandmother. Um, and then, for my wife's side, she's pure Kikuyu. So, well, and most Kikuyus are mixed with Maasai.
yeah.
So
I
she's main
understand.
exactly. So she's
Yeah,
mainly Kikuyu, but she's Kikuyu Maasai. And so now my children are sharing my mixed heritage and the strength of a pure Kenyan, of pure Kenyan ancestry, because it's good to not have to do a test to know where you come from. But
Yeah.
I wasn't that lucky. So I am going to learn how to do the test to figure out where I come from genetically.
Yeah. Yeah. This is definitely something we want to push as one of our key applications at the Black Blockchain Summit. Of course, doing it securely and anonymously so that people can protect their data, as you very well said during your presentation. So I'll leave it to you to give maybe your final thoughts on the future of AI, things that we should look out for going forward.
Okay, so AI is you have different people saying different things. You have a lot of rich guys going on TV saying AI is so good you won't need to code anymore and all this other stuff. And um, we're going to come into general artificial intelligence, artificial general intelligence, very quickly. And artificial general intelligence is an AI so powerful that it is smarter than and can manage anything that a human does. Um, so, these things are, it's easier to see them coming, but they're not as close as people are saying.
Yeah.
And that's one thing. Number two, it's never good to not understand things that can control you. So computer algorithms are already controlling the all of our futures. So it's best to understand and study those things. And as artificial intelligence is getting to be so powerful, especially generative artificial intelligence has been found to be so powerful, and that's just getting more powerful each month. Uh, we have to keep learning, and we have to understand well how this technology came about and how not just how to use it, that's the easy part, but how to build it ourselves. Because if we're not understanding that, we are going to get lost in the shuffle. So we really need to pay attention to this causal inference and machine learning. We really need to pay attention to, uh, not giving away our genomes. We shouldn't be giving away our genomes when you have these different um, registries and commercial companies that will sequence your genome and tell you where you're from. And when I was going to do that a few years ago, but I read the fine print, and the fine print says they once they sequence my genome, they can do anything they want with it, and they own it. And
Yeah.
it's a bit insane to say you own someone else's genetic information. You own the rights to use it whatever way you see fit. So we need to be very careful. Um, because the world is going to keep moving forward quickly, and we need to slow certain things down.
Yeah. Awesome. Awesome.
Cool.
Thank you, Dr. Daniel. That was a great presentation. We look forward to having you in person at the Black Blockchain Summit.